Alright guys, here's a quick tutorial on chemical reactions and properties. I'm going to start by reviewing the three reactions that we worked on together in class, or the three possible reactions. And we're going to focus on interpreting the data first, because data interpretation was an area that a lot of you identified as a weakness. And we're also going to look at patterns, which is another area that a lot of you identified as a weakness. So let's start with the reactions themselves. Water, density of 1.0 grams per milliliter, melting point of 0. Oleic acid, not soluble in water, density of 0.887, melting point of 13 degrees. Mix them together, what do you get? You get water, same properties, oleic acid, same properties. So how do you interpret these data? Well, nothing changed. The reactants were the same as the products, same properties all the way down. So, interpretation, does a chemical reaction occur? How do you know? No, a chemical reaction did not occur. The properties of the substances did not change. Water still was water, same density, same melting point. Oleic acid, same density, same melting point. Okay. So what kind of pattern is going on here? Well, there's a pattern of no change, right? We have the same stuff at the beginning and end. Okay, so patterns don't have to be super complicated, right? Patterns can be as simple as no change, or change and change, change and change, change and change. So in this case, no change is our pattern. All right, let's look at burning sugar. That was another reaction we did together in class. We burned some sugar. So what happens when you burn sugar? Well, you start with sugar and oxygen, and you end up with carbon dioxide and water. This is this smoke. It kind of looked like smoke and gas that was being released in class. A chunk of that was carbon dioxide, a chunk of that was water. So how do we interpret this reaction? How do we interpret these data? Well, we start with sugar, which is soluble, density of 1.58, melting point of 160. Oxygen, soluble in water, density of 0.0014, and melting point of negative 219. We end up with carbon dioxide, which is soluble, but it has a density that's different from either sugar or oxygen, right? It's a little more dense than oxygen is. What about its melting point? Well, also different, right? Melting point of sugar is 160, melting point of oxygen, negative 219, carbon dioxide, negative 78. So the properties of carbon dioxide are different from the properties of either sugar or oxygen. We also get water from this reaction. Density of water, 1.0 grams per milliliter. Melting point, 0 degrees Celsius. So again, properties are different of water than oxygen or sugar. So our interpretation, did a chemical reaction occur? Yes, it occurred, because the properties of the products are different from the properties of the reactants. So what about a pattern here? Well, we've definitely got a pattern of change, right? We go from having a solid and a gas to having a gas and something that's a liquid at room temperature. That's an interesting pattern, right? Solid, gas, gas, liquid. Solubility doesn't really change. Everything's still soluble. Density, though, is very interesting. We go from having a high, well, not a high, but a moderate density and a super low density to a slightly super low density, slightly less super low density, and something that's a little bit lower. Okay, so we have two extremes for our reactants, and the products are a little bit in between those extremes. So we have low density, super low, low, okay? But again, they're somewhere between, okay? So that's an interesting pattern. Melting point, we go from something that has a pretty high melting point, 160, and a super low melting point, to something that has a moderately low melting point and another moderately low melting point. And again, notice the properties of the products are between the range of the properties of the reactants. So that's a really interesting pattern that we're seeing here. 160 to 119, 78 to 0. Properties are different, but they fall in between a range. So that's an interesting pattern. All right. Last reaction, zinc and hydrochloric acid. We did this together in class. We watched the YouTube video of it. We start with zinc. We drop it in some acid. What do we get? A lot of bubbling, and the zinc slowly disappears and becomes a substance called zinc chloride. So what's going on here? Well, zinc is not soluble in water, has a density of 7.14 grams per milliliter, and a melting point of 419.5. Hydrochloric acid is soluble, has a fairly low density, 0.8 grams per milliliter, and a melting point of negative 114. What do they produce? Well, zinc chloride is soluble. So zinc goes from being insoluble to being soluble as zinc chloride. Density 2.91 grams per milliliter, melting point of 290. Properties of zinc chloride are definitely different than the properties of hydrochloric acid or zinc. Different densities, different melting points. Hydrogen, also soluble in water, very reactive substance, super duper duper low density, lower even than the density of oxygen or carbon dioxide. Melting point really, really, really low, negative 259. So, properties of hydrogen different from the properties of hydrochloric acid or zinc. Interpretation, did a chemical reaction occur? Yes, a chemical reaction did occur because the properties of the products are different from the properties of the reactants. What kind of pattern? Well, we go from insoluble, soluble to soluble, soluble. That's an interesting pattern. And our densities are different. We go from high density to moderately low density to kind of low density to super duper low density. That's an interesting pattern, right? High, kind of drops, a little bit higher, and then really, really drops. Melting point, we've got positive, negative, positive, negative. That's an interesting pattern. We go from a really high melting point to a kind of high melting point. And we go from a negative melting point to a really super duper low melting point. So that's your tutorial. Good luck when you take the next quiz. The reaction you're going to look at is going to be different from any of these, but look for, on the interpretation side, do the properties of the products, are they different from the properties of the reactants? And on the pattern side, patterns can be very different, okay, from reaction to reaction. All you've really got to do is identify something that changed and how does it change, right? Solubility changed, melting points changed, melting points fell within a range, or you could do positive, negative, negative, 0, positive, negative, positive, negative. Okay, a lot of different patterns that you could identify. I'd be happy with any of them. So, good luck, guys. Study hard. You can do this.